यार अरे पहले बड़े पर्सन में बताओ लेट क्यों हो, फिर मैं बताऊंगा तुम्हें। नहीं, एक्सक्यूज मी, क्लास का टाइम हो गया ना, डेडिकेटेड टाइम है, उसमें इधर उधर नहीं होना है। तुम लोगों के लिए बैठ के मस्जिद में दुआएं कर रहा हो तुम।
माशाल्लाह सर।
और यहाँ पे उमर को लग रहा है सर इधर उधर हुए हैं, तो वो भी इधर उधर हो गए। यार देख लो, चलो क्या याद करोगे। यार देखो, ये जो वेव्स घूम रही होती है ना, ये वेव्स जा रही है, तो इनके वेव्स के जो टॉप वाले पार्ट, उसको क्या कहते हैं, पहले ये बताओ फिर मैं आगे बढ़ाऊंगा। कोई भी बता दे, चलो। बताओ बताओ।
क्रैश।
क्रेस्ट, ठीक है। अगर क्रेस्ट क्रेस्ट को ज्वाइन कर दें इस तरह से, तो ये जो लाइंस होंगी ना, स्ट्रेट लाइंस, अब हम जो है ना कभी भी ये नहीं बनाएंगे जब वेव्स बनानी होगी, तो बल्कि हम ये स्ट्रेट लाइंस बनाएंगे। अब आपके दिमाग में आ रहा है कि स्ट्रेट लाइंस कैसे आ रही है, इमेजनरी लाइंस है कि हमने इन सबको ज्वाइन कर दिया है। कौन रह गया था भाई, से याद आ गया, ओके। So this is how the waves are reflected. All right. So Omar, just look here. This ray and these lines will be given to you. Okay. And then when it hits over here, it's going to reflect. So how are you going to do this? You'll be given this only. Okay. Where the point of incidence is, you are going to draw a straight line that's called the normal line. You're going to put your protector all the way like this, and this angle has to be measured. Whatever this angle is coming out, now you put your protector the other way, and the same angle has to be drawn at this side. Okay, arrows are to be drawn like this and this, and you have to measure this gap in between, because this gap has to be kept constant between these waves as well, because the wavelength is not to be changed. This can be possibly a 3 mark question. Mhm, mhm. Exactly, they can give you the left or the right parallel lines. All right, beta. So taking the measurements, exactly the ruler and the protector to do everything. Okay, done. The recording is started. Okay, that's great. Alhamdulillah. So the next one, if the barrier is inclined like this, okay, and the wave front is just like hitting it like this, okay. This is one of the wave fronts. That is the other one. Okay, let's first see what happens to one of them. So this wave front has struck the barrier and the barrier is inclined. Now you guys are going to draw a normal line like this. Okay, normal line must be perpendicular to the barrier. Normal line must be perpendicular to the barrier. Okay, now you're going to put your protector all the way around like this, okay, because this angle has to be measured. So put your protector, this angle and this angle, they should be equal. All right. So how are we going to measure this angle? We can place our protector over here, okay, and measure this angle. Now put your protector the other way and measure the angle, okay. You are grown up, so I'm not like going to tell you how to measure the angle on the protector. So this is going to go like this. All right. So if they've given you the waves coming like this and this and this, okay. So you're going to measure the gaps in between the waves. They're going to be the wavelengths, and then you can draw waves over here. So this is how the water waves are reflected. Make sure that these two angles must be same. This is the barrier, okay. So this was the incident wave. Incident is the one which is hitting, and these are the. So don't forget to draw the arrow. Okay, have a note of this. All right, all of you must be done with this. So how can we observe this phenomena of reflection in our daily life? For that, we have an instrument which is called the ripple tank. Okay. For O level students, the ripple tank. For O level students, even you can be asked to draw the ripple tank, but it's not to be drawn in the IGCSEs. Ripple tank is something like this, and it's a tank. Okay, it consists of water, and there is a screen lying beneath it. Okay, on the floor. We put a dipper over here. The dipper is the vibrator which is going to cause the waves. If you have circular dipper, so circular waves will be formed. If you have, okay, and this is connected to a motor, and over here we have a lamp which illuminates it. Okay, so if you want to draw the ripple tank looks like this. All right, so like the water waves will be generated like this. Okay, so there's water over here. As soon as this starts vibrating, so you can see ripples and being generated over here. Okay, so you can observe different phenomena in this. You can see like reflection. For reflection, what you do, you put a barrier over here, so these waves are going to hit and then come back. You put something like this, so these waves are going to hit and then come back in that direction. So whatever phenomena you want to observe, okay, and when the waves are going like this, so these patterns are being observed at the screen beneath it. Okay, so over here we have water, and this is the vibrator, this is the lamp, this is basically the vibrator, and we could call that to be a dipper. This is screen. All right, connected to motor. I'll share some video links with you guys. You can observe that how the dipper tank works, and once you see it visually, it's going to be really good for you. Okay, can we move on?
Yes, sir.
Okay, if someone is drawing, just ask them. Take your time. Okay,
सर वैसे रिपल टैंक के थ्रू डायफ्रैक्शन की वेव्स प्रोड्यूस होंगी.
Diffraction, refraction, refraction, all three can occur depending on what type of instrument you're placing in between the waves.
सर लेकिन वाइब्रेशन के थ्रू सिर्फ डायफ्रैक्शन नहीं हो सकता, जैसे बस डायफ्रैक्शन के थ्रू जैसे.
Diffraction is when you place an obstacle and the waves are going to spread through the obstacle. Okay.
अच्छा ठीक है.
So for diffraction, we have to put something over here like this. Only then the waves will be diffracted. Okay, and it will go like this. Getting?
जी सर.
Next page. Okay. Okay, sound waves are longitudinal waves. We studied yesterday. Sound waves are longitudinal waves. And longitudinal waves, we studied that they have two parts. They are the parts which are closer, and we have parts which are far away. And then the parts which are closer, and then the parts which are far away. All right. So the parts which are closer, we call them compression. And the parts which are far away, we call them rarefactions. Okay. For instance, you are being asked to draw the wavelength for this. Okay. So for instance, I take the center of a compression and a center of a compression. That's going to be one wavelength. Okay. Or a center of a rarefaction or a center of a rarefaction, and that's going to be the other wavelength. So if you're being asked to describe compression and the definition comes in the exam, so you're going to write high pressure zones where particles are close to each other. Okay. And make the rarefaction just the opposite of this. So rarefactions are going to be low pressure zones particles are far from each other. Is Saad in the class? No, it's not. Saad Rafi is not in the class. Okay. Okay. Okay, so these definitions might be asked in the exam.
ठीक है सर.
Okay. So now let's get back to the topic, and that was a reflection, a refraction, and diffraction. So because I come across with a question that has sound waves, and I just missed out that I must tell my kids about the compression and rarefaction. Okay, so basically what happens, sound waves are pushing the air. Okay, and when they're pushing the air particles, so sometimes they have the particles getting closer, and sometimes the particles are getting farther. So we have two regions, compressions and rarefactions, and it keeps on moving on and on. Okay. Can anyone tell me why can we see the flash, the thunder flash first, and the sound is after the flash being heard? What is the answer? Yeah, very good. Light waves are faster in sound. And why can we see the sunlight, but we cannot hear the explosions that are taking place in the core of the sun? MashaAllah. Oh, and just check out.
सर आई एम मर हमें पता है
Okay, great. Keep it up, my boys. Okay. Okay. So these are basically in this they have given us the direction of travel. This is the direction of travel. That has been given to us is 8.5 meters. Then how many waves? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So it's P and Q over here. And this is a wall. Okay. So the figure shows compressions of the incident wave. Basically, this is a sound wave coming. Compression of incident sound in the direction of wave travel. Okay. And we have to complete the figure of 3 compressions of reflected sound wave. So how are we going to do this? My dear students, the very first thing you guys are going to do, wherever this point is hitting, you are going to draw a perpendicular line on this. Okay. You can either extend it beyond as well. No worries. Is it done? Okay. Now we're going to measure the same angle. I've already told you guys how to measure that. You put your protector over here. This angle has to be measured because the same angle is going to be over there. So you're going to put your protector like this and measure this angle. Okay. Now you're going to put your protector. You have to measure this angle. Okay. So how you're going to do this? The protector was put like this. Again, this angle was measured. Okay. Now you have to measure this angle, this angle. So you have to put your protector all the way around like this. Is this clear to all of you?
यस सर
Put the
जी सर
protector like this. Then a yellow line is not to be measured. Yellow line is to be drawn randomly. It is at 90 degree to this. It is a perpendicular line. This is called the normal line. This is called the normal line. Okay. Whatever the angle this one is, because this is the incident wave, so the same angle should be on the other way. Okay. So now we have drawn this. Okay. We have drawn this. You get it? Okay. Something like this. All right. And either you can like proceed this line as well. You can proceed this as well. No worries. All right. Now, my dear students, these wave fronts are always perpendicular to the direction. Okay. So you have to remember this. Wave front are always perpendicular to direction. Direction line is drawn with a red color. And okay, so this was the first one. Now we have this one as well. So we are going to draw lines, okay, that are going to be perpendicular lines and any three compressions, okay. So you must remember you have to take care of two things. Number one, this gap must be the same between the two lines, okay, and the lines must be perpendicular on the red line. So this is the first one, okay. They might, because I haven't taken the measurements, these lines must be perpendicular to this line, okay. Number one, number two, and they should be parallel, okay, equidistant parallel lines, and this can be the third one. Is it clear? When you draw using measurements, so it's going to be even more accurate. This is the first one. These lines should be perpendicular. First one, second one, and you can draw the third one like this. Who is going to repeat that famous statement which I always used to ask when someone joins in the class?
Assalamu alaikum, sir.
Walaikum assalam. Saad, where you had been? It's like 45 minutes the class has been.
Sir, मैं बाहर था इसलिए.
Oh, I thought you forgot about the class. Do inform me whenever you are not there in the class, okay?
Okay, sir.
You'll be provided the recording, inshallah, so you can just join from there.
Okay, sir.
Is this clear to all of you? Okay, so I'll give you the questions and you're just going to take the printouts and you're going to do it using measurements. So that's going to be really easy for you guys. Okay. Refraction is one of the most difficult things, like not very difficult refraction, but like refraction requires some concepts. Okay. So I'm not going into refraction. First, we will do diffraction and we'll spend a whole class for refraction. Okay. So I'm not hurrying up. Slowly, guys. So let's talk about diffraction, okay? Diffraction. What is diffraction of waves? Okay, kids, you must remember that when there is a reflection of any wave, let it be water wave, let it be light wave, sound wave, whatever, you won't find a change in speed. There won't be any change in the frequency. There won't be any change in the wavelength. The reason being because thing is just hitting and going back in the same medium with the same angle. Only the direction is reversed. Okay. Speed slows down when the medium changes. For example, light waves are coming from air and they just enter the glass. Or sound waves have come from somewhere where there was like air and there was like it entered metal. Okay. Or water waves entered from a shallower region to a deeper region. Then you can see that there is going to be a change in speed because the particles will face some hindrance in moving out. Okay. So that's the thing. All right, so let's talk about diffraction and then we'll be going to refraction. So diffraction is basically the spreading up of waves after passing an obstacle. Spreading of waves after passing an obstacle. Okay. So for example, you are having water waves coming like this. and now you have placed a barrier or an obstacle in their place. Okay. So now what's going to happen if this is equal to the wavelength? If the slit or the gap, okay, if this equal to the wavelength, so when the waves are going to pass it, they're going to bend like this, and you will have curves. Okay. So for this, you can draw it randomly, or you can use your protector. How you're going to draw? You are going to measure this distance. Okay, this distance needs to be measured. You're going to put your protector over here and draw the first arc. Okay, then you double the distance. Okay, for instance, the distance from here to here. You put your protector over here and draw it. Then you will double it, and with the same center, you draw the bigger arc. And then doubling it, okay, you same center, you draw. Okay, so this is going to be the pattern. This is one of the most frequently asked questions in your exams. Okay, and it's really easy. Diffraction is really easy. You don't need to bother. This can be horizontal or vertical. Okay, can be like this as well. So you must not be confused about this. Like sometimes, okay, like this. So the direction of wave motion was like this in this case, and now it's coming like this. Okay, so now as the waves are entering here, and there's a barrier. So when the waves come, they are going to bend. Okay, so this is the diffraction of wave. Make sure that whenever you have the width of the gap, yes, बहुत ज्यादा फर्क पड़ेगा, वही तो बता रहा हूँ. वो जो the gap must be equal to the wavelength. Okay, the gap must be equal to the wavelength. Now what happens if we increase the gap? Okay, if we increase the gap, so there's going to be a drastic change in this. First you copy down this, then I'll let you know. Okay. Now you guys can observe that the width is like bigger, isn't it?
Yes, sir.
Okay, or even like so what's going to happen? You increase the width and the curvature is going to decrease. Now the waves are going to be something like this. वो जो उसका curve था ना, that's going to decrease, and they're going to be straight. The pattern will change from circular to straight and increase the width. And if it's so big that the waves can easily pass, then they're going to be just straight. Okay. So shorter or narrower the gap is, the more circular the wave patterns are going to be. Okay. So you just have to look whether the gap is equal to or bigger than the wavelength. This is the wavelength. Okay. And this is quite bigger than that. So these waves, which were once being turned like circular paths, will now be drawn like this. Okay. And for this, the only thing you're going to consider is the distance must be equal between these lines, and you're just going to draw that randomly with a pencil. None of the drawings in your paper must be drawn with a pen. Make sure about this. Okay. Sharp pencil and with like sharp and dark pencil. Sharpened, sharp हुई. Sharpened and dark pencil. Okay. You don't use blunt pencils. Brow is clear. So this was diffraction. Okay. And it's really easy. Okay. Yes. Like where you got the physics top? Where do you get the physics topic is from? Oh my goodness. Can you share it to me as well? Is it confidential? If it's not, you can share because there is nowhere when I haven't found physics PDF so far for paper 4. Believe me, for topicals. Yeah, to be honest, nowhere. Please share. So that's going to benefit all of us. Somewhat. Okay. I'll share the questions with you. Okay. I'll go into the past papers. Like some old papers, 2016, 2017 papers have more variety of questions like this in which you have to do. Okay. So the homework is going to be all of you must take printouts for the PDF I'm going to send. Okay. Refraction is leftover. And the refraction we are going to do it inshallah in the next class. Okay. So refraction we have to do in the next class and we have done with diffraction and reflection is done. Okay. So inshallah in the next class कल नहीं है class ये मसला है
कल मेरी और शाहजैन की क्लास है
so in meanwhile inshallah ta'ala we'll be doing so once we are done with this then we are going to talk about the light waves and we'll be discussing about total interreflection about the lenses so hopefully by the next week you'll be done with most of the things that are in waves okay refraction is left no it's not I'm really making it simple okay ओके जी तो आज थोड़ी छोटी क्लास करते और दूसरा ये कि फिर टॉपिक कंप्लीट हो गया क्योंकि दूसरा टॉपिक आई एम नॉट लाइक मेकिंग यू गाइस डू दैट if there are any questions related to the topics we have covered you can message me for them okay and I hope it's clear okay just okay and make sure that all of you must have access to the videos which are being recorded in the class okay so that you can easily watch them if there's any doubts or queries okay and inshallah we'll be solving past papers as well for waves once we are completed okay all right
Sir.
okay
Done.
or Omar what you can do is you can share the link on the group as well okay Mhm. Uh-huh. Okay. 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 So do share to me as well. Okay. All right. Share the past papers in this as well. Okay. All right. All right. All right. Zainab and Ali, you are going to join in 10 minutes. Okay. For the next class. Okay.